Hello, in this video we're going to learn how to solve game matrix, which is of the form 2 cross n or m cross 2. So if you look at this matrix, the size of this matrix is 2 rows and 4 columns, so 2 by 4. So this is of the form 2 by n. So in order to solve this matrix, the steps we need to do is first we need to check for the saddle point. So if you use the minimax method to check the saddle point, you will see that there is no saddle point in this problem. Step 2, what we do is we use the dominance method to see if we can reduce this matrix. When you try that, you will see that you cannot use the dominance method either over here. So then what we do is, since this is matrix of the form 2 cross n, we can use the graphical technique here. Okay, so in order to use the graphical technique, let me see if I can delete this bit. Okay, so I'm not able to delete it, but in order to use the graphical technique, what you need to do is make a table. Now just make a note. Okay, sorry about that. I'm just going to try and edit that. Okay, so just make a note, just because this game does not have a saddle point, it means it will have no pure strategies. Okay, so if there are no pure strategies, it'll move on to mixed strategies. Okay, mixed strategies means we will find the probability that player A will choose strategy A1 or A2, or player B, or what is the probability that player B will choose strategies B1, B2, B3, B4. So for that, what we need to do is make a table. Let's say it looks like this, and say these are B strategies, and these are A's expected strategies. A's expected strategies. Now, whichever player has only two strategies, if you look in the game, player A has 2 strategies. So whichever player has only 2 strategies, we will find that player's expected strategies. And we'll assume that B has pure strategies, which are B1, B2, B3, and B4 from the given table. If you look here. And we will find A's expected strategies. For that, what we need to do is define the probability. So we say, let P1 be the probability that player A chooses strategy A1. And let P2 be the strategy. Similarly, that A chooses A2. Okay, so how do we find the expected payoffs for player A? What we do is we look at the matrix and we multiply 2 times the probability of A1, which is P1, plus 4 times P2. That will be if player B chooses strategy B1. Similarly, if player B chooses strategy B2, then A's payoff will be 2 times P1 plus 3 times P2, and so on. So B3's will be 3 times P1 plus 2 times P2. So let's see how does that look like. So for A strategy, it will be 2 times P1 plus 4 times P2. And the other thing to remember here is that the sum of the probabilities will always be equal to 1. Okay, so if P1 plus P2 is equal to 1, P2 will be 1 minus P1. So what we do is in place of P2, you plug in 1 minus P1. So the problem becomes 2P1 plus 4, 1 minus P1, which when simplified becomes 4 minus 2P1. Similarly, we find A's expected payoffs if B chooses B2. It will be 2 times P1 plus 3 times P2. So you should get 2 times P1 plus 3 times P2. Okay, similarly do the same thing. In place of P2, plug in 1 minus P1. And when you simplify that, you should get 3 minus P1. Similarly, if B chooses B3, A's expected payoff from the above matrix will be 3P1 plus 2P2. Again, in place of P2, plug in 1 minus P1. When simplified, you should get 2 plus P1. And similarly for P4 or B4, we get negative P1 plus 6P2. And when simplified, you should get 6 minus 7P1. Okay, so we end up with 4 linear equations. 1, 2, 3, 4, corresponding to the strategies of player B. Now what you need to do is graph these things and find the intersection point. So let's see how to do that. Delete this for now. Okay, so we have the 4 equations. I'm going to write them down here. 4 minus 2P1, 3 minus P1, 2 plus P1, and 6 minus 7P1. So what we do is we graph these 4 on an axis. So this is the p-axis. This is P1 equal to 0, the line. And also remember, the probabilities will always be between 0 and 1. Make another line. It should be a straight line where P1 is equal to 1. So draw these 4 lines between these 2 lines. Okay, so how do we graph the first one? In place of P1, you plug in 0, you get 4. Let's see somewhere here, 4. And in place of P1, plug in 1. You get 4 minus 2, 2. So somewhere here. Okay, and connect the 2 dots with a straight line. This is the payoff for player A, the expected payoff for player A, if B1, player B chooses B1. It's not 2B1, it's B1, this line. Okay, similarly, graph the next one. In place of P1, plug in 0, so you get 3. That's the first point. In place of P1, plug in 1, you get 2, same thing. So you connect this two things. Okay, and this is your B2. Okay, for this one, in place of P1, plug in 0, we get 2, is the first point. And the second point, we get 3. Okay, so this is your next one. This is B3. And similarly for this one, plug in P1 to be 0. We get 6, which is slightly up here. And in place of P1, plug in 1. We get 6 minus 7, which is negative 1. Somewhere here. And connect the two dots. Okay, let's do it properly. Okay, it should be a straight line, but this is a bit messy because of the pen. So it should be a straight line, and you will see that it goes through this point as well. Okay, so these are the expected payoffs for player A. Now, the main thing to remember here is when we're finding the expected payoff for player A does maxi min, and player B does mini max. So we're doing player A here, so you need to look for maxi min. Look at the minimum points first and take the maximum of that. So if you look at this lines here, the minimum points for this line, this payoffs lie on this region or this lines. This is B4, by the way. Okay, so these are the minimum points. So you take minimum first and then take the maximum of that. So the maximum of these guys lie on the intersection here. So this point is maxi min. Okay, we took the minimum first and then the maximum of that. So in order to find these points, we take the intersection of the lines that connects it. So if you look closely, B2, B3, and B4 connect at that point. So if 3 lines connect at the point, we can pick any 2. So let's pick B2 and B3. Okay, so this was B1, this is B2, B3, and B4. Okay, so to find the intersection of the 2 points, of the 2 lines, we make the 2 lines equal to each other. Okay, weird. Moves. So let me move this up again. Okay, so I'm just going to delete this to make it look better. So remember, we need to make B2 and B3 equal to each other to find the intersection point. That's what we're going to do, but I'm going to delete that first. Okay, so make B2 equals B3. To get the intersection point, B2 was 3 minus P1 equals 2 plus P1. And then solve for P1. We get P1 equals 0.5 or half. Okay, so we found the probability P1 to be half. Similarly, we know that P1 plus P2 equals 1. So P2 will also be half. So we find the probability P1 that player A will play strategy A1 to be 50%. And we found the probability P2 that player A will choose probability strategy A2, which is again 50%. Is this a coincidence that it's turned out to be 50%? But not always. You also need to find one more thing, the value of the game. So to find the value of the game in B2 or B3, in place of P1, you plug in 0.5. So 3 minus 0.5 gives you 2.5. That's the value of the game. So now make a note, if the value of the game is positive, it means player A is going to win this game. If it turns out to be negative, player B will win the game. So we find the probability P1 and P2 that player A picks strategy A1 and player B picks strategy, player A picks strategy A2. The probability of that is 50%. Now we find the probabilities for player A, we need to find the probabilities for player B. We do it the same way. So let's see how to do that. Let me delete this. Let's go back to the matrix that we had. So this is player A, A1, A2, player B, B1, B2, B3, B4. This was the matrix 2, 2, 3, negative 1, 4, 3, 2, 6. Okay, so we do the same thing. Say let Q1, Q2, Q3, and Q4 be the probabilities that B chooses B1, B chooses B2, B3, and B4, and so on. And remember, Q1 plus Q2 plus Q3 plus Q4 should always equal to 1. So now, in order to find the expected payoffs for player B, what we did was, for A, we did 2 times this, 4 times that. We do the opposite here, the row times the probabilities. Now, the other thing to note here is when we found the answers for player A, we only used B2 and B3. So it means that only B2 and B3 will contribute to the probabilities of player B. So you can just get rid of this column and this column. So the values that we end up here, the expected payoffs, will be 2Q2 plus 3Q3. So Q1 and Q4 are 0. That's what it means. So in this equation as well, this and this cancels out. They're zeros. And similarly, we get 3Q2 plus 2Q3. So we do the same thing. In place of Q3, we write 1 minus Q2. So this equation becomes 2Q2 plus 3, 1 minus Q2. And this linear equation becomes 3Q2 plus 2, 1 minus Q2. Because Q3 is 1 minus Q2, just like before. Now, in this case, you don't need to solve or graph these equations because there are only 2 equations. We know that they will intersect, for this problem at least. And so all you have to do is make them equal to each other and solve for Q2 and Q3. Okay, so when you do that, I've already done this here on a paper, so I know the answers. The answer is 0.5 again here. and 0.5 again here. Just a coincidence that it's 0.5 here, and even for the other ones, it may not be the same thing all the time. And in this case as well, you need to find the value of the game. And you will notice that if you find the value of the game by plugging in the values in these two equations or any one of them, it'll be 2.5. So you can just make a note that the value of the game in both cases will be the same. If they turn out to be different, it means you're making some mistake. Okay, so this is how we get the probabilities for player B as well. And it will always happen that two of the probabilities are 0. And you don't have to graph when you're solving for player B. Okay, and the value of the game will be same in both cases. So let's just recap. First, we find the probabilities of player A, which has only two strategies. And then we do the same thing to find the probabilities of player B by doing the same technique. You don't have to graph for player B, but you do have to graph for player A and look for maximum. Okay, if any questions, you can put it below in the comments.